what would you do with it?
So, make a really small bed for my really small brain.
That's a good idea. Is that spontaneous? That was pretty good.
Yeah.
Okay. What I would do with my piece of wire is I would make it into a square and a circle so that I would be prepared for the test on Thursday. Okay? All right. You guys have, I said a quiz today, but it's this worksheet that you picked up. You can just do it for homework if you don't have time. Okay? I like to answer questions today. I'm going to be around during lunch and after school today, but I'm not going to be around tomorrow. Like I'll be around in class, but I have a dentist appointment and I won't be back except to pick up my kid. All right? So FYI, I'm not going to be helping out. I can't help you tomorrow during lunch and after school, but I can today. All right? So if you have questions, hopefully you have all your homework done and you're ready to ask questions. All right. Let us talk about this problem here on our right side. Your quiz, FYI, guys, you need to show your work. We had a formula quiz in first period today, and second period, I just wasn't watching the clock, and we did not have time. So we'll see what happens in this class, okay? If you don't have your formula quiz today, it'll be tomorrow. Okay, guys, one of the questions on your test looks just like this. This is all it says. Okay, actually, it may say more. It may say, use linear approximation to find the square root of 226. But guys, this is all that's on your test. And a lot of people on this question on the test, Katie and Ruchi, are you with me? A lot of people on this test, like all they do is they just leave it blank, okay? Because they've seen this before, but they have no idea what to do. So guys, what are you going to do when I say use linear approximation to find this? Find a formula. Does that make sense? Get a function, okay? Because you're going to have to take a derivative. We can't take a derivative if you don't even have a function. Okay, how do you figure out the function? Point slope, okay.
You take the scary number and you cross out the scary number.
Turn the scary number into an x. Well, guys, there's only one number here, okay? Turn it into an x. So what's my function? Do you see it?
Root x.
It's the square root of x. Guys, you need to make a function first, okay? And I'm not going to tell you what the function is. You're going to have to give me the problem. Okay, the problem here is the function is square root of x, okay? And then I heard point slope. Guys, to do linear approximation or to find an approximation using a tangent line, you will need a tangent line, okay? So you need to say, I need to find a point and I need to find a slope. Okay, now I'm in trouble. What's my point?
You can make
one.
Okay, I make one. What's a good point to make?
225.
225, okay? So right here what a lot of students do wrong is they do a lot of things wrong besides leaving it blank, is instead of 225, they'll put 226.
No.
Okay.
So wrong.
Now well let's talk this through though. What's wrong with putting 226 here?
It's the scary.
Yeah, because if you put 226 here, your y, remember f of x is a code word for what? Y. Your y is going to be the square root of 226. Guys, you're right back to where you started.
Whoa.
Like, now what do? I'm right back. This was my problem in the first place, okay? I just recreated my same problem. That did not help, okay? So that's why you have to be smart about this and pick a number that you could actually take the square root of, okay? Does everybody see what we're doing here? Maybe if I make a picture that will help, okay? But guys, you need to be able to do this on your own. This is the square root of x. That's what we said is the function, okay? What we're trying to do is we're trying to find the y value when this is 226. So if this is 226, do you understand? If I can find the y value of this, this would be my answer. That's what we're trying to do. But what we're saying is, you know what, without a calculator, we can't find the square root of 226, okay? But we do know the square root of 225. And where did that 225 come from? Yeah, it's close. Some of you guys, it came from your brain. Other guys, you're going to have to pull it out of your rear, okay? But either way, you need to get 225, okay? So right here, this right here is your 225, so here's 225. And when I get 225, what I do is I go up here and I draw a tangent line right at 225. And when I do that tangent line, what I realize is, you know what? My tangent line right there looks an awful lot like my function, okay? So I'm going to use my tangent line to approximate what the y value of 226 is. It's really hard to use my function because I don't know the square root of 226. But using a tangent line, I can actually do it. All right, So what is the tangent line here? I've got a point. What's my slope? It's going to be the slope of a tangent line. What is that? What is the slope of a tangent line? It's the derivative, okay? And if you were taking your formula quiz, that's one of the questions on your formula quiz, okay? Give me another word for the derivative. Give me actually 2 more words for the derivative. What are 2 more words for the derivative? Instantaneous rate of change and the slope of a tangent line. All right, so the derivative here is going to be, is everybody okay with taking this derivative? Are you comfortable with that? Okay, it might help if you rewrite this, but there's the derivative of square root of x, and that actually can also be written like that, okay? But I don't want something with an x in it. I want to change this into a number because I need a slope of I need a tangent line equation, okay? So how can I change the slope of a tangent line to a number? Plug in my x. Now, am I going to plug in 226 or am I going to plug in 225? 225. Again, guys, if you plug in 226, you're going to be right back where you started. What is the square root of 226? I don't know, okay? So you're going to plug in 225, so this is the f prime of 225, and that's going to be 1 over 2 times 15, is that right? Mm-hmm. So it's going to be 1 over 30, okay? What do you do next?
Now that's your slope.
There's your slope. There's your point. So I'm going to write the point slope formula, okay, for a linear equation. So y minus, ooh, this is really just 15. You guys okay with that?
Yeah.
Y minus y is equal to the slope times x minus x. All right, what do I do next? I got the equation of a tangent line. What am I going to plug in? What am I trying to find? I'm trying to find y when x is what? 226, okay? And the key to the whole thing is you pretend that you don't have a calculator, okay? And so you do it without a calculator, the square root of 226. You're approximating it, okay? But guys, on your test, you're really going to have a calculator. So you can trick me, okay? You don't actually have to do this in your head. You can just put it in your calculator, and you'll get the 226 minus 225, okay? You'll trick me. I'll never know that you used the calculator for that, okay? All right, so this answer for y is going to be, see if this makes sense, 15 plus 1 over 30.
Yeah.
Okay, so that's going to be 1 over 3 is actually 0.3333, right? But if I divide it by another 10, that's going to be 0.3333, right? And on your test, I think I say go 5 decimal places, okay? So make sure you go at least 5. If you go more, I'll just ignore your numbers, all right? But go at least 5, okay? And there's your answer, okay? That's the approximation for the square root of 226, okay? But that would be too easy if I stopped there on your test, okay? What I'll ask you on your test is this an under approximation or an over approximation? And use calculus to justify it, okay? Is it an over approximation or under approximation? Over. How do you know it's an over?
Because look at that.
If you look at the picture, okay? If you look at the picture, if you have something that's concave down, which means the second derivative is negative, if you put a tangent, if you slap a tangent line on it, this is the approximation using a tangent line. The tangent line will always be above, right? Always be greater than the actual curve, okay? Does everybody understand that? So what you would write, actually, even without the calculus, you could actually just write the actual is above the approximation because the second derivative is what? Less than 0. Is everybody good with that? You can, actually, I've already done the problem. I just need to show my work, okay? This is your answer. Let me make this a little bit clearer. It's not that the derivative is less than 0. It's the second derivative at what point? 225. Does that make sense? You need to be looking at the concavity right here, or somewhere right here. You could put 225, you could put 226 there, it doesn't matter. But either 226 or 225 is the point that you're looking at. All right, so let me show my work, okay? So what I need to do is go find the second derivative. So if you get this far, that's great, but I see that you never found the second derivative, then I'm going to take off a point. Okay, you need to find the second derivative. So do you see, if the first derivative is this, the second derivative is negative 1/4 x to the, take this down by 1, so it would be x to the negative 3/2. Okay, this looks really scary, okay, but you can change it to this. Is everybody good with that? And that's a lot less scarier. That's what the second derivative is. And really,
Negative.
we just need, oops, thank you. We just need to know if this second derivative is positive or negative, right? So if you plug in 225 there, or if you plug in 226, is this going to be positive or negative? Negative. Do you see that no matter what? So, yeah, Danny.
Isn't the other way around approximate is greater than actual?
Oh, yeah. Did I write? Ooh.
Nice,
Bad.
Danny.
Yeah. Thank you, Danny. Okay. Yeah, that's way better. Yeah, your approximate, because that's your tangent line, is greater than your actual. Awesome. Thank you for catching that. Okay. So your approximate is greater than your actual. So guys, right here, is this going to be a negative or a positive? It doesn't matter which one I plug in. What's it going to be? A negative. Okay. And so you know that f double prime at 220, and it doesn't matter. I could say 226. 225 is easier to plug in, so I'll say 225 is equal to a negative number. So therefore, that's true. And now this is actually true. It wasn't true before, but Danny fixed it. Okay. Any questions on how to do this problem on your test? Yeah, Carla.
So if the x value was like greater than 226,
It would still be the everything would be exactly the same. Why? Let's say I said, you mean 220, you mean smaller.
Yeah.
Well, when you say 226,
Like if it was,
like if I picked a number over here,
yeah.
224, right?
Yeah.
So look at what happens if I do 224. It would still be, like everything would still be the same. The derivative would still be the same. This would still be the same. I would still pick 225 here. The only thing that would change is, the actual number, that point, whatever number I had, 15.0333, that would be different, okay? But everything else here would be actually the same.
So the justification would be the same?
Justification would be exactly the same. Yeah, good point. Okay, because it's still concave down no matter where I pick. Okay. All right. Any other questions? Okay. Go ahead and pass up your warm-ups. Let me see what I have for you guys here. I had a problem here that I worked in first period, but then they kind of like lost interest. So what I'm going to do is just ask you guys questions. Okay. You have your homework out. Let's ask questions from your homework, or let's ask questions for your optimization. Can you do the swimmer problem? You guys still having problems with the swimmer problem? Can you do the square circle problem? Okay, those are definitely on your test. What questions did you have? Square circle. Which number do you want to do?
Any.
Pick one for me.
Oh, geez, I don't even remember which one.
You want to do number 8 on your homework?
Yeah.
Okay. Let's do number 8 on your homework. Number 8 says find the maximum. This is your previous homework. Optimization one. I think the length of your wire, if I remember, was 4. You guys can correct me if I'm wrong. Was it 4? And I'm going to split this wire into a circle and a square. If it's not 4, somebody correct me. Okay, it's 4. I'm going to split this wire into a circle and a square. And you want to maximize the what? Area. Guys, if you want to maximize the area, you need to find the area first. It's maximizing the total area, right? So the total area is pi r squared plus x squared. Is that right? Okay. Guys, if you want to maximize area, what are you going to take the derivative of? Area. If you take the derivative of this, do you see you have two different variables? So you're going to do implicit differentiation. Raise your hand if you want to do implicit differentiation. Nobody raise their hand. So let's do something else, okay? How do you avoid using implicit differentiation? Get a constraint. Get another equation. What other equation do I have here? The circumference. If I take this wire and I split it into a circle and a square, this is a square, okay? Isn't this part of this length that you turned it into a circle, isn't that 2 pi r? And what's this length right over here? 4x. So what's your constraint equation? 2 pi r plus 4x is equal to 4, right? So basically you have an area equation and you have a perimeter equation. And what I've been doing is I've been solving for r consistently, so I'm going to keep it consistent. But you could actually solve for x. It really doesn't matter, okay? But if you do it enough times one way, just keep it that way because you know you're doing it right. If I solve for r, you get 2 minus 2x over pi, right? Okay, so I'm going to plug that into this r squared here. So let me just go ahead and find r squared. Now be careful. This is the FOIL r squared. Does that make sense? You don't just square this term and this term. You got to actually FOIL it, okay? Those of you guys who are middle children, You get that, right? You get that you don't lose that middle child. That's terrible, okay? So this would be 4 minus 8x plus 4x squared over pi squared. Let me know if I did that wrong, but trying to do it in my head. All right, so this is what your r squared is. If this is my r squared, do you see I go over here and multiply it by pi, right? So let me go ahead and find my new area here. My new area in terms of all x's is going to be 4 minus 8x plus 4x squared over pi squared. But if I multiply this by pi, then do you see it would just be over pi here. Okay, so I'm just going to leave that over pi plus x squared. Okay, so let me erase this thing so it's not too terrible. Okay, so I found my area in terms of one variable. That's great. What do I do next?
Separate them.
Separate them. Yeah, do a common denominator. Actually, we're preparing, just like you guys are preparing for college, right here, we're preparing to take the derivative. Okay, so the easiest way to take the derivative is you see this common denominator. Okay, guys, you can only do it if you have a heart. Well, a triple heart. Okay, this is a triple heart. Okay, but you can't if you have an upside down heart. Does that make sense? Okay, it's only if you have one denominator that's common down here. All right.
Minus 8.
Oh, is that an 8 minus? Thank you. Okay, I'm so glad I'm not taking your test. Okay, everything else is good? Okay, what's the next step? Yeah, Optimus Prime, right? Okay, so if you looked at Optimus, if you talked to him, maybe you would get it. You'd be like, oh, prime, got it. Take the prime, okay? So what's the derivative of 4 over pi? 0. What's the derivative of negative 8 pi over x? Negative 8 over pi. What's the derivative of 4 over pi x squared? 8 over pi x plus 2x, okay? I've taken the derivative. What do I do with it? Set it equal to 0 or dne. So this will be equal to 0 or 1 over 0. But you understand, when it's 1 over 0, that's, you run into a problem when you have a denominator that has an x. Does that make sense? And there's no denominator with an x here. So what's going to happen here is I'll get pi equal to 0, and I'll get no critical points. Okay, I'll let you guys do that one on your own. And you don't have to show it. If there are no critical points, you don't actually have to show your work. Okay? But over here, I actually get x is equal to 8 over pi over 2 plus 8 over pi. Right? Okay, I'm going to pull all the x's to one side and just solve. That's the algebra part. I took some shortcuts, but I think you guys can do this part. All right? So what I'm going to do is I'm going to go into my calculator, okay, and I'm going to figure out what this is. And you'll have your calculator for your test. So you'll just do 2 plus 8 divided by pi. Did I do that right? I think I did. You guys have this on your homework, right?
Yeah.
Okay, and then I invert that. So I take the reciprocal of that, and I multiply the reciprocal times 8 divided by second pi. Okay, and my answer is 0.56001, so 0.5600099, and I'm going to stow that as A. Okay, so I'm going to hit stow, alpha A, I'm going to stow that as A, just in case I need it again. I'm not 100% sure I need it again, but I cannot use rounded numbers, okay, if I need to find anything else. So I'm going to stow that as A. Guys, if this is my A, what's my R going to be? Plug into this, do you see, plug into this R equation right here. So everybody good with that? If I know x, I can find r. So let me just go ahead and find my r just in case I need it. I take my x, I multiply by negative 2. Okay, multiply by negative 2. Then I add 2 to that answer. And then I divide by pi. Okay, oops. How do I get that back? Oh, second answer. Second answer divided by pi. Okay, and I'm getting 0.280050. Okay. So this is going to be R is equal to 0.280050, and that's going to be B. I'm going to stow that as B. I'm not sure that I need to stow it, but I'm going to go ahead and stow it just in case I need it back because I don't want to type all of this stuff. All right, so that's my B. So what's the question? What's the question? Was it to minimize or maximize area? Maximize. Okay, well, let's just see if this is a maximum or a minimum, okay? So what you would do for this problem, for other problems, you don't really have to do a number line, okay? But this problem, if I do an A prime number line and I put in my critical points, and remember, my critical points were, I don't even remember, oh, you have to choose. Do you want your X critical point or your or your R critical point. You can only have one, okay? Do you have a question, Brent, or are you just stretching? Okay, so this is A prime, and I'm going to choose my X critical point. X equals 0.560099, all right? Guys, you wouldn't put your R and your X on the same number line, okay? Your critical points are your X values. It's either going to be R values or X values. It wouldn't be both, okay? That maximize or minimize A, okay? Remember, this is an A prime number line. Guys, if you want to maximize or minimize A, you have to take the derivative of A. Is everybody good with that? On your test, when I ask you to maximize or minimize velocity, what are you going to take the derivative of? Velocity. Does that make sense? So if I give you position, and you take the derivative of position, have you taken the derivative of velocity? No. So you need to do it twice. Does that make sense?
Yeah.
Okay. So we've had that on homework. But anyway, so I'm going to pick two numbers, one to the left of 0.56 and one to the right of 0.56. What's a good number to the left of 0.56? 0. What's a good number to the right? 1. Yeah, I'm going to use 1. Okay, you'll see why. Okay, if I plug in 0, what equation am I plugging into? A prime. This is an A prime number line. So I'm going to use this A prime right here, okay? If I plug in 0, do you see you get negative 8 over pi? If I plug in 1, do you see these two numbers cancel out to 0? So if I plug in 1, do you see I get positive 2? Okay? So what's happening to the A here? I'm heading down, A is decreasing, then A is increasing. So if I'm trying to maximize my A, where is my maximum A happening at? Endpoint. Does that make sense? Okay, so if they ask you for the minimum, if they ask you to minimize A, you're going to say, and I don't know if I ask you to justify, I'm pretty sure I don't, okay? You're going to say, look, there's only one critical point. To the left of this critical point, your slope is always negative. To the right of this critical point, your slope is always positive. Therefore, this min must be an absolute min. Do you remember that justification, okay? It's coming back to us, all right? But if they ask you for a max, okay, it's going to happen at either this point or this point. How do I know which one's the maximum area? Yeah, you're going to try them, and it's just the maximum area. Like, if this is 3 and this is 5, then 5 is the maximum area. Does that make sense? If this is 0 and this is 2, then 2 is the maximum area. It's just the biggest number. All right, so now you got to use some logic. To get the endpoints, you need some endpoints, right? This is an x, okay? Think about what x is. X is what? X is the dimensions of the square, right? What's the smallest x that you can have? 0, right? It wouldn't be negative, right? Because it's a geometry problem. So the smallest x you can have is 0. So I'm going to put 0 here. Okay, what's the biggest x you can have? There's some logic here. What's the biggest x? Yeah, the biggest x you could have is if you take this, your wire is 4, right? So the biggest x you could have is if you take this wire and you folded it into a square, or you bent it into a square, and that would cause my x here to be 1. Guys, if my x is 1, what's my r equal to? If I took this and made this 1, 1, 1, 1, what's my r going to be equal to? 0. So over here, when x is 1, r is going to be 0. Guys, over here, when x is 0, what's r going to be? And x is, if this was 0, and this was 0, and this was 0, and this was 0, what would my r be? 2 over pi. It would be 4, it would be 2 pi r. That whole circle plus 0 is equal to 4, right? You're going to, this whole length is going to be 4, but your square was not existent. So your r is going to be 4 divided by 2 pi, or 2 over pi. Does everybody see where I'm getting my numbers? All right? So all I have to do is, if I know x and 0, can I find my a? I'm sorry, if I know x and r, can I find my a? Yeah. So you plug it into your a equation. Whichever one is bigger, that's going to be your maximum area. Okay? So let me delete this. I don't think I need a prime anymore. Okay? So right here, when x is equal to 0 and r is equal to 2 pi, my area is equal to pi r squared plus 0, right? Pi r squared plus x squared, which is equal to 4 over pi. Okay, what about this problem here? When my x is equal to 1 and my r is equal to 0, what's the area there? Area is equal to pi r squared, oh, that's just 0 squared, plus 1 squared, which is 1. Which one's bigger, 4 over pi or 1? 4 over pi, okay? So what you need to write is the area is maximized when entire wire is circle. I know I left out some words, that's just because I'm an immigrant. You guys put the words in, okay? But it's when you take the whole wire and you make a circle, right? When you have no, when, did I say circle? Wait, is that a circle? Yeah, okay. This one I did wrong then. Oh no, this is when there's no circle. Okay, this one's a square, yeah. Okay, so I did that right. When there is a circle. Okay, guys, I don't know how many times we need to do this problem, but guys, do you see the maximum area is always going to happen when what happens? When you make a circle. It's always going to be that situation, okay? So if I ask you that on the test, it would be too easy. So I'm not going to ask you for the maximum area. I'm going to ask you for the minimum area. Does that make sense? Because the minimum area, you have to do all this work. That's way more fun, okay, than just telling me your answer is a circle. Okay, so FYI, that's what's going to be on the test. Make sure you know how to do it. All the work before we found this weird maximum thing. Okay, and you don't have to justify in your test either. Okay, what other questions do you have from homework? Last night's homework okay?
Number 16.
On
The
optimization, yes, let's do 16. Is that the cost one?
Yes.
Okay, so let's look at number 16, guys.
Are there going to be cost questions on the test?
No, but it's good to know. So I can actually set it up for you, and if you want to keep on continuing, I'll do it. Okay, but it's actually a good question because the setup is a lot like number 15 setup. Okay, and a lot like your test, sorry. Okay, so guys, what we have is this is 8 miles. Okay, we have this is 6 miles. This is A, this is W, and this is B. And is this a pipeline problem? They're laying some pipe, and they want to tell you that it costs $100,000 per mile. This cost over here is $100,000 to lay pipe underwater per mile, right? And then this cost is $75,000. So the cost here is $75,000 per mile to lay pipe over here. Okay. So guys, we're trying to minimize costs. I'm assuming. What does it say to maximize or minimize? Minimize. So I'm trying to minimize my cost. Okay, see if this makes sense. If you're trying to minimize your cost, you need to write an equation for cost and take the derivative of it. You agree? Okay, so let's write the equation for cost. Now, if I wanted the cost to lay the pipe, well, if I knew the length of this pipe, so let's say I laid 10 feet of pipe here. Wouldn't the cost be 10 times 100,000, right? So let's just figure out how many feet this is here. And the way you do it is just the way you do every single problem here. You always call this x. Guys, if you call something else x, okay, you're going to be in a lot of trouble. I'm just letting you know. The problem's just going to explode, okay? You could probably do it, okay, but there might be a lot of dust and ashes near your desk, okay? So this is x. Guys, if this is x, what's this length? 8 minus x. Guys, that's something you should be able to do quickly as soon as you get this problem. Okay? If this is x and this is 6 and this is 8 minus x, what is the length of this piece?
The root of x squared plus 36.
Okay? And those are all distances that you should write right away when you get this problem on your test. Okay? And then you realize that these are distances, but what you want to maximize or minimize is cost. So you got to get the cost. Well, guys, if this is the length and this is the cost per length, then isn't the cost of this red line of laying that pipe, isn't that 100,000 times x squared plus 36, right? And what's the cost of this laying this pipe over here? Isn't that 75,000 times 8 minus x? Okay, so there's your equation, all right? So you have the equation for cost, and what do you want to do when you after you have the equation? Well, check variables first. I don't want to do implicit differentiation. So do I only have one variable? Yeah, so I'm good there too. So I don't need a constraint, right? If you had 2 variables, you want to go find another equation. All right, so all I'm going to do is take the what, guys? Take the derivative. And if you take the derivative of this, I'll change it to that. It's 100,000 divided by 2 times x squared plus 36 raised to the, be careful, guys. A lot of students miss this part right here. What do you do when you take 1/2 down by 1? It's negative 1/2. And here's the other part people miss. What do you do after you take the power down by 1? Guys, take the derivative of the inside. Okay. This one's a lot easier if you distribute it first, if you distribute it first, let me do it in a different color, you'll just see that the derivative of this is actually, well, I was hoping to do it in a different color, but maybe not. It's 0 minus 15,000. Oh, is that 75? Oh, thank you. Minus 70, thank you. Minus 75. Okay, and so I've taken the derivative. What's 100,000 divided by 2? Oh, wait. See this 2?
Yeah.
The 2's cancel out. Okay, so you've got C. What do I do next? Set it equal to 0. Did I find the derivative already? Yes. Okay, so you set this equal to 0 or what? DNE. So what I have is 100,000 over the square, 100,000 x, right? Don't forget that x. That's what I did wrong. Okay, over the square root of x squared plus 36 minus 75,000. That's equal to 0, or 100,000 x over the square root of x squared plus 36 minus 75,000 is equal to 1 over 0. Okay? Guys, when you do this right side, what you're saying is, when does this not happen? When does this thing explode? And this thing explodes when you have a 0 in the denominator. Does that make sense? So if you want to not do the common denominator stuff, you can just set this bottom equal to 0, and you will have when this thing explodes. So this thing explodes when you have a critical point at x equals plus or minus, be careful, not plus or minus 36, square root of 36. It's plus or minus negative, right? Square root of negative 36. So what's the answer here? There is no critical point. Okay, be very careful with this, guys. On this side, though, what do you want to do? Can we divide everything by 1,000? Okay, so then what we'll get is 100 over the square root of x squared plus 36 is equal to 75. This is really over 1.
There's an X in the numerator.
Oh, did I forget it again? Okay, thank you. Unbelievable. Yeah. Okay. And then what are you guys going to do here? Cross multiply. Can you cross multiply? You have one fraction left, one fraction right, and equal sign in the middle. Yes, if you cross multiply, you'll get that. Then what do I do? Can I simplify a little bit? This 100 divided by 25 is 4, right? And this 75 divided by 25 is 3. Okay, now what do you do?
Now you can like
Square both sides. Guys, check my squaring out. Are you guys good with how to square both sides? Make sure you're comfortable with the algebra. Okay, and then what do you do next? Let's try and still solve for x. I'm really upset. X is still not within my reach. Distribute that 9, and you'll get 7x squared is equal to 36 times 9, whatever that is. 36 times 9, 4, 5. What's 27 plus 5? 32? I'm getting, is it 324?
Yeah.
Okay, so x squared is going to be the square root of 324 plus or minus, well, no, sorry, not, oh, sorry. X is going to be plus or minus square root of 324 over square root of 7. What's the square root of 324? Is it 18? I have no idea. I'll go with that. So plus or minus 18 over square root of 7. Guys, look at your x value. Can it be negative? Go look at your x. No, it's a distance. All right, so we're just going to go with the plus. Okay, that's your x. Guys, make sure you answer the question, though. What's the question? The cost. Is 18 over square root of 7 the cost? No, it's the x value that minimizes the cost. Does that make sense? So you go back up to the top, and I'll let you guys do that. You have a calculator. Plug x into your cost equation. Guys, don't plug it into C prime, because if you do that, you should get 0. Okay? Plug it into your cost equation, and that's your answer. All right? Okay, what other questions do you guys have? You guys are good? Totally good. Yes, Afi?
Did you do the minimum on number 6
What is number 6? What kind of problem is it?
for the optimization?
Optimization. Okay. So number 6.